let's look at some examples of sampling variability in polling for elections. So here we have 4 different plots. These are 4 states, and it shows before the 2016 election what the polls were showing. For example, this dot here says that about 85 or so days before the election, Hillary Clinton was ahead in the polls by 12 or 13 points or so. And so you can see they've put a trend line in each of these that kind of shows the trend over time. But you can see like even 2 polls on different days gave very different results. Like these 2 dots were just like a day apart, but they gave different results. So people don't really change their mind on who they're voting for president that quickly. What happens is that different polls give different results because they all use, some sort of more or less random sample of people. And occasionally there's a weird poll like this one showed Hillary Clinton was like 25 points ahead, but that was sort of the outlier. Most of them weren't like that. So even though most of these were showing Hillary Clinton with a very sizable advantage, occasionally one of them was showing Trump, but the majority of the polls were showing Clinton was going to win Michigan no problem. And then, of course, when actually election day came, we can read this. The election day estimate was the black filled in circle, and the true outcome was the white not filled in diamond is the name of that shape. I need to go back to kindergarten, I think. So we can see that even though the polls were showing this, the outcome ended up otherwise. And a similar thing happened in Nevada. Well, actually, Nevada was different in that the polling was very, very close. Some polls showed Hillary Clinton with a slight lead. Some showed Donald Trump with a very slight lead. And then on election day, it turned out Hillary Clinton won by quite a bit, defying predictions there too. But Pennsylvania and Wisconsin show very similar stories to Michigan. There's a lot of sampling variability. The polls were all over the map, up and down, but they really showed Hillary Clinton with a pretty sizable advantage. Then on election day, it turned out the other way. And of course, the reasons for that are beyond the scope of this video, but let's look at a little bit more sampling variability in polling with this party affiliation. So this is just polling people on what party do you affiliate with from 2004 to present. Present in this case, I think was 2018. I need to start noting where I get these graphics, but the source was Gallup, which is a big polling organization. The other one I got from some random political science blog or something, which I probably should have written down. But anyway, so you can see if you just look at the percent of people identifying as Democrats, they put in a trend line again. And the trend line is kind of up and down, which might reflect national trends. But realistically, a lot of these dots are very close in time, but they have a lot of up and down spread, which is just this idea of sampling variability. People didn't really change their party affiliation that quickly, that often. It's just that different polls using different groups of people give different results. And so you need to put a lot of them together to see the overall trend. And it'd be interesting because you see party affiliation is sort of decreasing for both of our major parties and going up for people who don't really want to be affiliated with either one. It'd be interesting to get similar data and see what happened to these trend lines over the next 3 years. But we'll just have to wait and let history unfold, I suppose.